Okay, so if you've just got done watching Scientific Method Notes, you guys will realize that there's going to be a little section for kind of supplemental notes. And part of this supplemental notes is how to make a good graph. We do a lot of graphing of the data that you guys collect, and we want to make sure that you guys are displaying the information the way that you should. So whether you are doing them on the computer or you are doing them by hand, either way works for us because you're going to be shipping them in or sending them in through Google Classroom. And if you are doing them by hand, easy. Snap a quick picture with your phone, attach it to one of the files that you have that you're sending in. So after you're done the experiment and you kind of collected all of your data and you're analyzing it now, one of the ways to analyze it, you've made your data chart and it's kind of displayed there for you and it's kind of easy for you to read, but now you want to display it in this graph form. So one of the things you guys, after you make that organized data table, you want to make sure that you label it. What's the information in that data table telling you? Make sure you have units. Okay, so we just went through that with the peat moss scenario that you guys had with your Scientific Method notes. You guys should have your name on it someplace. Okay, so name and date and maybe your class period, since there are so many different class periods. Stick that up in the top left hand corner of that paper, either on the computer that you're creating it on, the program that you're creating it on, or if you're just doing it by hand. You need to think of a good, interesting title, and you want to make sure that title basically indicates what that graph is telling us. Graph 1, Graph A, Science Graph, those are not good titles. Water holding capacity of peat moss is a good title if you're thinking about that peat moss scenario. What is that X and Y axis information telling me as I'm looking at it? What is that line that we're looking at there, or the bars that we're looking at there, basically telling me? The next thing is, not even on here, so let's take a quick little break. Sometimes you guys will be asked to create a bar graph. Maybe you guys are doing a line graph. Maybe we're doing a pie graph somewhere along the line. If you're not sure when to display those types of information, underneath this tab of supplemental information, you guys will see when to create what type of graph. So go back through that if you have to. The majority of the graphs that you guys are going to be creating for us are going to be line graphs just because of the relationship that we have. Bar graphs kind of are usually displaying things that really don't relate too much together. It's a little bit harder to put them in a line graph, so we usually put them within a bar graph. But like I said, most of the ones that you guys will be doing are going to be line graphs. Just keep that in mind. But give yourself a good, interesting title. Put that in the top portion, top center of your graph paper. You guys want to make sure you use the entire piece of graph paper. So if this is my graph paper here, I don't really want to make a little graph that looks like this. I want to make sure that I'm utilizing the entire piece of graph paper. And the reason is, don't make me little itty bitty graphs. It helps to display my data a little bit better. It gives you a better idea of what that data is going to look like. So we'll make sure that we use the entire piece on that. You guys need to identify the independent and dependent variables. And yes, put them on there. So down along that bottom axis, that horizontal line, make sure that you guys are labeling it independent axis or independent variable, x-axis, dependent variable, y-axis. Put that information there. And then you guys need to label them. So what information is going on that independent variable? What type of information is going on a dependent variable? So if you think back to that peat moss scenario that we just did, your independent variable, what you were controlling is how much percent of peat moss was added to sand. So we could say like container A, 100% sand, container B, 80% sand, 20% peat moss, something along those lines. But that's what we're controlling. Along that y-axis, what are my results of the information that I put on that x-axis? So for the peat moss scenario, once again, it was the amount of water that was absorbed. We need to put units. You will lose points without those units. So it was in milliliters. Okay, otherwise could it be in gallons, could it be in ounces, could it be in cups? Make sure that you put those particular units there. The scale, hugely important. So as you guys are going across and you're looking at that X and Y axis, so I need to label it. I'm going to say, okay, every block is going to equal this. Well, you need to make sure that every block is going to be the same. So if I'm starting out 0 here, and I want to count by 2s, 2, 4, 6, 8. I can't just say, oh, let me put a 2 here, I'm going to put 6 here, and 10 here, and I'm good. I need to make sure that every line has the same units all the way across. They just can't plop numbers in there. Otherwise, that line that you're creating or those bars that you're creating are not going to be a good indication of the data that you just created for us. So make sure that the increments are even on both the X and Y axis. Plot your points. So go through, plot those points on that particular data chart. You want to make sure that you're doing this in pencil if you're doing them by hand. If the graph is linear, you guys are connecting the points using a ruler. Linear, nice straight line. I connect them all. They all fit within that nice straight line. If not, you guys are going to do a best fit line. I'll show you an example of that in a moment. If the graph is not linear, go ahead and connect those points and just kind of give me that nice smooth curve along the way there. If two or more sets of data are placed on the same axis or same graph, make sure that you guys are using color coding it. So first line red, that's data A. Second line B, that's data B, or the blue line. So I may have something like this. So I could say, okay, well, let's look at a little example, and we're looking at the effect of exercise on heart rate. So we have a bunch of people, and they're doing jumping jacks, and we want to see what their heart rate is in the beginning and what their heart rate is after they do so much time of jumping jacks there. So on my x-axis, I'm controlling it. I'm going to tell them, okay, let's do jumping jacks for this amount of time. I can't control their heart rate. I can't say, okay, let's make sure your heart rate is 150 when we're done this. I can say, let's do jumping jacks for a minute. Let's do jumping jacks for 3 minutes. Let's do jumping jacks for 6 minutes. And we can test that heart rate there. Make sure that I have the same scale all the way through. And then I have a scale that goes along the X or along the Y axis. Okay. You're going to notice this little zigzag line here along the Y axis. What that indicates is that I have no points before that 70 beats per minute. So I don't need to start out 0, 10, 20, 30, 40, 50, 60, 70, because what happens is that all my data is going to be shoved up into this little corner. So if I have no points plotted before 70 on this particular one, then I can do a little zigzag and make my first number 70. If it was 50, this number would have been 50. If it was 120, I could have put a 120 there and gone through. And what it does is it spreads out my data and makes it a little easier for me to be able to decipher the information within it. I can do the same thing along that x-axis if I wanted to. If I didn't start taking those recorded measurements until 3 minutes in, maybe I want to spread it out. First number would be 3. If I have a heart rate of 70, but somewhere along the line, one of my points dropped all the way down to 50, I can't just like kind of plot a point down here. I need to make sure that there are no points along the way. Go through, plot those particular points. Usually I'll tell you guys, just kind of go through and either do a best fit line, meaning you're putting a line in between kind of an average of all those particular points. Or I might say, give yourself a nice gentle little curve on those particular points. If you are doing a best fit line, that's my dotted line there. It's saying it's not a true picture of what's going on here. It's my kind of average that you may see within that particular pieces of information. If you have a piece of data and it is way off, so here's all my points and they seem to fit in there really, really well. And then all of a sudden I got this really weird piece of data all the way down here. I don't really think that it's true or a valid piece of information. So what I'm going to do, rather than going through and trying to put this within my line, I'm just going to circle that. And I'm going to put the rest of my line that fits between those particular points. And I'm going to say, this is a data point that I got, but for some reason, I'm not considering this piece of information. I'm considering that it may not be valid there. So I want to make sure that I show it, but I'm going to kind of circle it so it doesn't go through within that. There are times that you guys may have to extrapolate points, okay? So let's say these are the pieces of information that I have. And I might say, okay, well, within your temperature, we tested 20 degrees Celsius, 50 degrees Celsius, and 80 degrees Celsius. I might say, well, what do you expect to happen at 100 degrees Celsius? And what you would do is you just kind of make a dotted line there and dotted line here and say, okay, based on the trend that we see, that's what we're going to look for there. So this is the actual data that I had. This is what I can consider or create a hypothesis on what my data may look like beyond those particular points. Okay, so some things for you guys to remember. You guys want to make sure that your graph utilizes most of that page there. You want to make sure that your scale is correct on both X and Y axis. You want to label X and Y axis as independent and dependent variable. You want to make sure you label the information that you find here. So here it's temperature degrees Celsius. Here it's time in seconds. Make sure that you have that line within there, either you're connecting those dots. And one thing that we have, make sure you have a good title. So once again, can't be graph 1, graph 2, graph 3, super fizzers, something like that. It really doesn't tell me what you guys are looking at. Okay, great, super fizzers. What does that mean, the information? So think about that as you guys are working on that little activity that you guys will be seeing this week. All right, so this is extra information. You guys will see a bunch of extra information within this little topic folder on the side of Google Classroom, so check it out. You also have a little packet there that you guys can go back through. Like I said, check it out. What type of graph am I using? Am I doing a line graph, a bar graph? Maybe I'm doing a pie graph. But like I said, you guys will be graphing a lot of the information that you see here. So once again, any questions, please let us know.